was assigned problem 22 on homework 1. Part A reads, what is the frequency of blue light that has a wavelength of 450 nanometers? We can start this problem by first writing our knowns and unknowns. It's given that the wavelength is equal to 450 nanometers. Because we're talking about blue light here, we can use the speed of light, which is equal to 3.0 times 10 to the 8th meters per second. And we are solving for frequency. We can use the equation frequency is equal to the speed of light over wavelength to solve for frequency, because we have both the speed of light and the wavelength. We can plug in what we know. C is equal to 3.0 times 10 to the 8th meters per second. And because we're in meters here, we have to convert 450 nanometers into meters, and we can do that by multiplying 450 by 10 to the negative 9. We calculate this and we get 6.67 times 10 to the 14 hertz. The second part reads, what is the frequency of red light that has a wavelength of 650 nanometers? Again, we can start by writing our knowns and unknowns. We have that our wavelength is 650 nanometers. Speed of light, since we're still talking about light, red light this time, is equal to 3.0 times 10 to the 8 meters per second. And again, we're solving for frequency. We can use the same equation as above. F equals speed of light over wavelength. We can plug in what we have, 3.0 times 10 to the 8 meters per second. And again, wavelength is in nanometers, and we must convert that to meters by multiplying it by 10 to the negative 9. And we get frequency is equal to 4.62 times 10 to the 14 hertz. Part C reads, what is the index of refraction of a material in which the red light wavelength is 450 nanometers? We can use the wavelength from above, and we can also use the wavelength that is given in this problem, because we're talking about red light, and in part B we were also talking about red light. And to determine the index of refraction, we can use the equation lambda material is equal to lambda vacuum or wavelength over the index of refraction. We can rearrange this to solve for n, and we get n, or index of refraction, is equal to the wavelength of the vacuum over the wavelength of the material. We know that light waves slow down as they pass through transparent materials, and because of that, we can write 450 nanometers as our wavelength in material, because it is smaller than the wavelength up here at 650 nanometers. So we can write that our wavelength of material is equal to 450 nanometers, and our wavelength of the vacuum is equal to 650 nanometers. Because the wavelength in the material must be smaller than the wavelength in the vacuum, that has to hold true, because n, or the index of refraction, is a number that is greater than or equal to 1. And once we know that, we can simply plug in these wavelengths into the equation, and we get 650 nanometers over 450 nanometers, which is equal to 1.44. And that's it. Thank you.